Okay, we're going to start the last section here for the course, 11.10, which is Taylor and Maclaurin series. Okay, as definition, it says that the Taylor series of f is a function at a number a, is f of x equals the summation as n equals 0 to infinity of the nth derivative of f at a divided by n factorial times x minus a to the n. Okay, that's the nth derivative. Okay, not f of a to the nth power. Don't mix that up. Okay, and if we expand this out, let's see, when n is 0, 0 factorial is 1, right? And anything with 0 power is 1. So I've got f of 0, or excuse me, f of a, and then plus, when n is 1, I got the first derivative of f at a divided by 1 times x minus a to the first. Okay, plus when n is 2, we have the second derivative of f at a divided by 2 factorial times x minus a squared. And when n is 3, it's going to be f triple prime of a divided by 3 factorial times x minus a cubed, okay, plus etc. If a is 0, which will happen actually for a lot of these problems here, but if a is 0, the series is called the Maclaurin series for f. Okay, so like some calculus books will call this section just the Taylor series. Okay, since the Maclaurin series is kind of like one special case of the Taylor series when you're centering a series at 0. Okay, and by the way, it's going to be most convenient for us to center it at 0. Okay, just for the formulas that we end up getting there. All right, so let's take a look at these problems here. We're going to find the Maclaurin series for each function. Okay, so let's see. You have to know the derivatives. Okay, so f of x is e to the x. F prime of x is e to the x. F double prime of x is e to the x. F triple prime of x is e to the x, right? The derivative of e to the x is itself. Okay, so the nth derivative of f at x is e to the x. Now, a is 0 when you're working with the Maclaurin series. Okay, I'm finding a Maclaurin series for this function. So when I plug in 0 for f, anything to the 0 power is 1. F prime of 0 is 1. F double prime of 0 is 1, etc. The nth derivative of f at 0 is 1. Okay, so you're always going to get 1 up top right here in this part. Okay. Now with that said, so e to the x is going to be 1 plus 1 times x minus 0 is x, plus 1 divided by 2 factorial times x minus 0 squared is x squared divided by 2 factorial, plus 1 divided by 3 factorial times x minus 0 cubed, or that'd be x cubed over 3 factorial, plus x to the 4th over 4 factorial, plus etc. Okay, and yeah, if I were to write this using summation notation, okay, I've got the sum as n equals 0 to infinity of the nth derivative of f at 0 is always 1, right? And I'm dividing this by n factorial times x minus, the a value is 0, right? Because this is a Maclaurin series. A is 0. So times x to the n power, okay? So this would be the series form for e to the x. Okay, you got the summation as n equals 0 to infinity of x to the n divided by n factorial. Okay, now using the ratio test, you could find that the radius is infinity and the interval of convergence is negative infinity to infinity. Okay. And by the way, as a note, here's f of x is e to the x, right? F prime of x, if I were to find the derivative as a power series, that's going to be the same formula, right? Well, why is that? Well, because f of x equals e to the x, f prime of x is e to the x, so you're going to be doing the same thing. And so I end up getting the exact same formula there. Okay. Now, if we were to give a series expansion for just the number e, what does e look like? Okay. Well, x is 1, right? So you're going to have the summation as n equals 0 to infinity, 1 to any power is 1, divided by n factorial. And so that's going to be 1 plus 1 plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus etc. So if I add up all infinitely many of those terms, the grand total would be e. Okay. Let's try another example here. What if we had the function f of x equals sine x, and we want to find a power series for that function, or a Maclaurin series for that function? Okay, so the value of a is 0, again, for when I'm finding a Maclaurin series. Okay, f of x is sine x. Now I'm going to have to know the derivatives, right? Because the derivative is involved in the formula here, and a is 0. Okay, so let me just calculate the derivatives here first. F of x is sine x, f prime of x is cosine of x, f double prime of x, so the derivative of cosine of x is negative sine x. The derivative of negative sine x would be negative cosine x. The derivative of negative cosine x is the opposite of negative sine x, or just sine x, okay, for the fourth derivative of x, etc. So, and you're going to repeat what you just did there in the next group of 4 calculations, okay? Again, this is a Maclaurin series, so the value of a is 0, okay? F of 0, sine of 0 is 0. Cosine of 0 is 1. Sine of 0 is 0. Cosine of 1 is, or cosine of 0 is 1. There's the negative in front of that, though, so negative 1. Sine of 0 is 0. Right? So what's going to happen here is I'm going to go 0, 1, 0, negative 1, 0, 1, 0, negative 1, etc. And okay, so now I think I'm ready to give the series form. Okay, so here's the formula again. Okay, so sine x would be the nth derivative, or the f of 0 is where are we at here? F of 0 is 0. Okay, plus f prime of 0 is 1 times x minus 0 is x. Okay, so that's the first term that I've got there. And then plus f double prime of 0 is 0. Okay, 0 times anything is 0. All right, so that's going to knock out that part. F triple prime of 0 is negative 1. So I'm going to have minus x minus 0 cubed over 3 factorial. Okay, now what's going to happen here is because the terms alternate 0, 1, 0, negative 1, 0, 1, 0, negative 1, right? Then every other term is going to be 0. Okay, so, and this is an alternating series also. So the next term I'm going to have plus x to the 5th divided by 5 factorial, skip the next term, minus x to the 7th over 7 factorial, skip the next term, plus x to the 9th over 9 factorial, etc. Okay, and in power series notation form, we're going to have the summation as n equals 0 to infinity, right? That's what I got there, times let's see. Well, what's happening here is that I'm alternating sign. Okay, it goes positive, negative, positive, negative, positive, negative, right? So that's going to be a negative 1 to the n. If n is 0, the first term is plus. If n is 1, the next term is minus. If n is 2, the next term is plus. When n is 3, the next term is minus, right? And then times, okay, what's happening here is that the powers of x are just odd numbers. Okay, so I'm going to have x to the 2n plus 1 divided, and then whatever that odd power is, I'm dividing by its factorial in the denominator. Okay, and again, let me check this. So if n is 0, I got 1 times x to the first divided by 1 factorial is x. That was good. Okay. When n is 1, I'm going to have minus x cubed divided by 3 factorial. Yeah, that's what I got. Plus when n is 2, it's going to be plus x to the 5th divided by 5 factorial. Again, when n is 2. That's good. Okay. Minus when n is 3. Okay. You're going to have minus x to the 7th divided by 7 factorial. Okay, plus etc. Okay. Now, if you remember from section 11.8 here, we've already seen this series. Okay. Here's that series. This is 11.8 when I was first talking about power series. And we found that the radius is infinity and the interval of convergence is all real numbers, negative infinity to infinity, right? So, yeah, but that problem there, if you remember, I mentioned that this is a formula for sine x. Okay, so sine x is equal to the summation as n equals 0 to infinity of negative 1 to the n times x to the 2n plus 1 divided by 2n plus 1 factorial. Okay. Now, from this guy here, okay, what if I find another power series for cosine of x? Well, cosine of x, that's the derivative of sine x, right? And so I just need to take the derivatives of each one of these infinitely many terms. The derivative of x is 1, and then minus, I'm using the power rule, right? So minus 3 divided by 3 factorial, that'd be, the 3's cancel there, so it'll be 2 factorial in the denominator. X squared up top, and then plus x to the 4th divided by the 5's cancel there, so it'll be divided by 4 factorial, minus x to the 6th, and then the 7's would cancel, right, divided by 6 factorial, plus etc. Okay, so all I'm doing is taking the derivative of each one of these infinitely many terms using the power rule. Okay, well then if I use series notation, I have the summation as n equals 0 to infinity of negative 1 to the n, and again, I'm just taking the derivative here. So I bring down the power and then reduce the power by 1. So when I reduce the power by 1, I got 2n plus 1 minus 1, that's 2n. And then this 2n plus 1 came down, and it's going to cancel with the first term here on this factorial. Okay, so 2n plus 1 factorial, that's the same as 2n plus 1 times 2n minus 1 times 2n minus 2 times 2n minus 3, right? So the 2n plus 1's would cancel, leaving me with the 2n factorial there in the denominator. Okay, and yeah, so this would be a formula for cosine of x. Okay. Let's see, why don't we, well, actually, yeah, why don't we stop the video right here, and I'll pick up with this example in the next one there. Okay.